Hi, my name is Joshua from Tag. In this video, we would actually have the last part of the data operators we have in R, which is the special operators. So, without wasting much of our time, let's move straight to the practical section. So, here was where we stopped in the last video on the logical operators. So, I will still use the example of these empty cars dataset that we use with the special operators. So the first special operators we are learning is the full colon, this, and so I told us anytime we have this full colon, it is just trying to print out range of numbers. So if I create a variable and I call it vec, and I say vec is numbers from 2 to 5, that's what it means, 2 to 5. If you look at the global environment, we have a variable created called vec having numbers from 2, 3, 4, and 5. So that's all about the special operators. If you want to create like a range from so place to so place, and when we proceed, we will see the usage of some of these special operators, especially in manipulating our data using the dplyr package, TDR, etc. So the last example with the special operator that I would use, I won't talk about that of the percent multiplied by percent, where we use it for multiplying a matrix against its transpose, because here we are not really dealing with matrix. Maybe in subsequent videos where we'll be talking about algebra, vector manipulation, matrix, etc., we might talk about that. So I'll just stop at the level of the percent in percent. So this percent in percent is an interesting function we always use, like check a variable against another variable, and the result is always going to be something logical. So this is what I mean. Let's take, for instance, okay, we have salaries. Let me print out salaries. So I will say print, or you can just write salaries. I will say print salaries. So I want to have an idea of the kind of salary. So I have a staff working with me that I pay €100, 20, 30, 50, 70, 85, 45, and 95. So for instance, I am saying, let me have a situation where I have, let me say msal this way as a variable, and here what msal stands for is values 20, 30, and 45. So if I run this, I have salaries and I have msal. So I'm asking a question. I can ask a question, like I want to factorize. I'm asking a question now by saying msal percent in percent of salaries. So what I'm saying is that, can I find values that I have in msal? Can I also find these values in salary? If I run this, it tells me true, true, and true, because in salaries I have 20 and I also have 20 in msal. I have 30 in salaries too. I have 45 in msal. The same thing is present in salaries. So let's take, for instance, I just modified this and I turn it to 105 and I change the value. You could check on the global environment, the value is changed from 45 to 105, and then I rerun this code. You would see that obviously the last one would give us false, because I only have msal 105 in msal, but 105 is not present in salaries. So that explains to us why we have false at that particular level. So let's see what we can do. There is an example coming to my mind. I don't know, maybe this will work. Okay, it doesn't really make any difference. So let me say salaries, and then I square this and I say msal percent in percent of salaries. Let's see what this will give us. So it prints out everything for us in this case, because we are indexing msal that is present in this, and then we're now saying, okay, how many times do we have it? And then we use that in getting the values we get to get the values that we have in the entire salary. So that's that about that. So another example I'm going to use is with the empty cars data set. So I'm going to create another variable. I'm going to call it CYG, for instance, and then I say CYG stores MPG, that's miles per gallon, and it stores the cylinder. So let's just stop at that level. I run CYG. So I'm asking a question now, and I'm going to use this function called names. I want to know the numbers of columns that we have in the empty cars data set and their names. So if I run this, I can see the names and the numbers. We have 7, 8, 9, 10, 11 columns we have inside the data set empty cars. So I'm asking a question. With this CYG, percent in percent of names empty cars. So if I run this, it tells me that it's true, that I can find MPG in the names of the columns we have in empty cars, and at the same time I can find CYL. So let's take, for instance, I just put my name, I just put Joshua and CYG, and I go back again to run this code. So you know now we have true, because MPG is part of the names we have in the column for this empty cars data set. This is MPG. But if you check through, you won't see any kind of column where we have Joshua, and that tells you why this is giving us this answer false. So it is also possible you could index, you could filter your column using some of these conditions, the column of a certain data set using this condition. So I will say empty cars indexing, I want it for all the rows, and what is the condition for the column? I'm saying names. I just want where we have this and CYL. So I'll say names of empty cars that is present in CYG. So if I run this, you will see it only print out the first two columns. To make this thing very clear, I can say head function, and then I can copy the entire line of code above it and impute it here, and then run this. So let me zoom the console pane so you could see this is just the result of the code we have run. So it will only index out the column with this particular condition, and what this condition is saying is that from the names of columns that we have in empty cars, print out those ones where we also have the values, the names that we have in CYG. So let's see what will happen. Let's try and see what will happen if I change this again back to Joshua and I run it, and I say CYG in this, and then I run this. We know why it is false, and then let's see what will happen if I just do this. So what happens here is that it only gives me the value of NPG and drops out that value of CYG. So here what it's saying is that names of columns that we have in empty cars, how many of them can we also find in CYG? It's just one, and that one is just this MPG. So the value we have here is just for the MPG. So let's take, for instance, I have Joshua and I said I also have CYL, and I run it. So let's say I come back to this particular place and I try this again. So I will have true for MPG, false for Joshua. Joshua is not present in that column, and then we have true for CYL. So if I run this, it is not just going to give me MPG alone now. It's going to take me back to those two columns where we have the miles per gallon and cylinder. So that's that about data operators in R. We have talked about the arithmetic operators. We have talked about the assignment operators in details. we have dealt with relational operators, we have talked of logical operators, and finally in this video where we talked about the special operators, the full colon and the percent in percent. So I want to bless you. Thank you. I want to say I'm grateful for your time to watch this video, and may God bless you. So if you are yet to subscribe, you can hit the subscribe button, and also turn on your notification bell so you would always have the first hand information on my videos. Thank you very much. God bless you. Bye bye.